Okay, so in this video, we are about to discuss what is momentum and uh, what would be its effects on the heavier or the lighter object, and some more uh, questions regarding the momentum. Okay, so first of all, momentum. We know that, let's say, whenever an object, let's say this is a mountain and there's an object on the mountain, so it rolls down and comes into motion. And this motion was already contained in this object. So we can say that momentum is the quantity of motion contained in an object. So it is a physical quantity we are trying to find the magnitude of the quantity of motion in a body. And let's see what all factors it depends on. And so momentum is, in simple layman's language, is the quantity of motion contained in a body. So, because the bodies are lighter and heavier, so that means the quantity of motion will also be less or greater in the body. So let's say how we are going to check if the quantity of motion is more or less in a certain body. So, quantity of motion contained in a body is called momentum. Now, it is how do we measure this? Because it's a quantity of motion, so we have to measure this. So it is measured as the product of mass and velocity. So because we are measuring it, we have to denote it as well. And it is denoted by small letter p. P. So momentum is small letter p. Now we have to measure it is the product. So P is the product. Momentum is the product of mass, which is denoted by M, and velocity, which is denoted by V. So momentum is equal to mass into product of mass and velocity. And from here, we can write down its SI unit as well. SI unit of mass is kg from the formula itself, and the velocity is SI unit is meter per second. So the SI unit of momentum is kg meter per second. Okay, now momentum will be higher for heavy object or light object. It's very obvious from the formula because momentum is measured as the product of mass and velocity. So let's say we have an object with both are moving with the same velocity. So let's say they are moving with the velocity of 10 meter per second, but here the mass of the first object is 10 kg and the mass of the second object is, let's say, 20 kg. So the mass of the so momentum of the first object, that is object A and object B. B is heavier, so momentum of the object A would be m1 into V. Velocity is same, so let's consider it as V, which is equal to 10 into 10, that would be equal to 100 kg meter per second. Now let's calculate the momentum of the second object, which is m2 into V. Mass of the second object is 20, velocity is same, which gives us 200 kg meter per second. Do remember to put in the SI units. Okay, so so the momentum of the heavier object is more as compared to the momentum of the lighter object. So we can say more is the mass, more is the momentum, or we can say that momentum is directly proportional to mass of the object. So heavier object will have higher momentum and the lighter object will have lower momentum. Okay, so whose momentum is higher, an object at higher speed or lower speed? So in this case, let's consider the same example. Let's say this is an object A, this is an object B. Now we have to vary the speed. So let's say mass of both these objects is 10 kg. So mass is same, so I'm going to keep it as m0, m1, and m2. Now the velocity of the first object is, let's say, 10 meter per second. and the velocity of the second object is, let's say, 20 meter per second. Let's calculate the momentum in both the cases. It's m into v1, which is equal to 10 into 10. That is equal to 100. And what is the SI unit? Kg meter per second. Let's calculate the momentum in this case. So this is m into v2. Mass is 10 into 20, which gives us 200. Don't forget to put in the SI units at 200. So the object with the greater velocity has greater momentum. Object with lower velocity has low momentum. So higher the speed, higher is the momentum. It's obvious from the formula because P is equal to m into v, and keeping the mass constant. If we keep the mass constant, it gives us P is directly proportional to v. So that means more is the velocity, more is the momentum. Okay, now what do you get after the change in momentum, or what is change in momentum? Before we move on to what is change in momentum, let's see what is change. So change is actually the final value minus initial value. Okay, now how do we find the change? Let's say a student scores in physics in, let's say, first term, he scores out of 30, he scores 20 marks. And in the second term, out of 30, he scores 30 marks. So this is the final score, and this is the initial score. And what exactly is the change? So change will be final score minus initial score. So final score is 30 minus 20, which is equal to 10. So 10 is the change, is how we calculate the change by subtracting the initial value from the final value. So if we have to find the change in momentum, so instead of the score, we will write, we are going to find the change in momentum. For that, we need the final and the initial momentum. So that would be final momentum minus initial momentum. Okay, what would be the final momentum? We know that momentum is given by P is equal to m into v, and usually we use v for the final velocity. So for final momentum, it's m into v final velocity, and if we have to calculate, this is the final momentum. And if we have to find out the initial momentum, so we will have, because mass will be constant, we just change the velocity, so that would be initial velocity. So initial velocity will m into u, and m is common, so we will write m into v minus u. So our change in momentum, it's mathematically written as m into v minus u. Okay, so this is change in momentum. How do we find, calculate the change in momentum? Next is the rate of change of momentum. Okay, we know that the change in momentum is given by final momentum, which is mv minus initial momentum. Now, what is rate of? Rate means the rate of change of momentum means we have to divide the change in momentum by time. So whenever there is a rate, you have to divide the change by the time. So change in momentum is given by m into v minus u, and time is t. So v minus u by t, we have already discussed it in motion chapter. It's change in velocity. Rate of change of velocity is acceleration. So instead of v minus u by t, we are going to replace it by a, and that m into a, we know that m into a is the force. We are going to discuss this later on. So for the time being, let's just keep that m into a, change rate of change of momentum is m into a, and which would be equal to force. We will discuss this in the next video. So for the time being, what is momentum is the quantity of motion contained in a body. It is measured as a product of mass and velocity denoted by P. Formula is mathematical expression is m into v, assigned it is kg per second. P is directly proportional to m. That means more is the mass, more is the momentum. P is directly proportional to v, more is the velocity, more is the momentum. And change in momentum gives is mathematically written as m into v. It's given by final minus initial momentum, which is m into v minus u. And rate of change of momentum, whenever there is rate, you have to divide the change by time. And change in momentum is given by v minus u. If we divide it by dv minus u by d is a, and m into a is f, which is the force. Okay, so we are done with the momentum, and let's move on to the next video. To like, share, subscribe. Thank you for watching.